Welcome to API Summit 2023 by Kong. And today, at this time, I'll be giving the talk. Yeah. Today, what I'll be talking about is handling observability from an API gateway perspective. So, it will largely be from the perspective of an API gateway, and largely as well, it will be stories and lessons from my experience at Grey Parrot. So, that's what we'll be looking at. My name is Matey Aryeh. I'm originally from Ghana, in Accra. I work for a company called Grey Parrot IO, where I serve as the CTO. I largely lead the team in our technical and engineering developments, as well as SRE. Now, in case anyone wanted to reach out to me after I've put my contacts in the slide on X and LinkedIn, I'm available. Like I said, I work for Grey Parrot, and it's an originally Ghanaian based technology provider. We largely deal with financial institutions. Currently, I'm recording this presentation from site. I'm here with a team. We are on site in Zambia, working on a digital transformation journey for one of the largest banks in the country. So that's what we do. In case anyone is out here from the financial space or has any questions, is interested, like I said, I put my contacts out, X and LinkedIn. You can reach out to me. We can have a chat. Yeah. So like I said, we're originally based in Ghana. We have presence in Zambia as well, where I'm recording from currently. And also we have presence in Cote d'Ivoire. So that's Grey Parrot, and that's myself as the introduction. So now we can move on to the more important things for the presentation. So I'll do a backstory. I'll take us back about 5 years, back to the early days of Grey Parrot, when we had just been founded. We had just started working on providing technology solutions and services for some of our first clients. Now, Grey Parrot isn't so old, so 5 years ago is just right about the beginning. I have to be about 7 or 8 years old right now. I lose track of the years, but yeah. And in this backstory, we had some number of issues. The first of which was service latencies. What are SLAs? That sounds like a very simple question, but it was one that was very difficult for us to answer, for me to answer. How long does it take for our services to respond? What guarantees are we giving to our clients? What guarantees can their downstream systems count on from our services that we provide to them, that we maintain for them? What are the SLAs? We didn't have any really. We couldn't measure. We didn't have a way to tell. What if the service health? When our services are up, do we know when was the last time our service was offline? Was the service ever up? Those are a lot of questions we used to ask ourselves, and we didn't have the concrete answers to, because we didn't have proper observability. What are error margins? Is the current error experiencing the result of an update? Is it the update that we just put on, or the patch we just put on, that is causing us to have this error? Why are we having this error? And if we have errors as well, usually you have some margins, you have some way to measure. Are we out of line with our errors, or are we within line with our errors? Because every system will have errors, every system will have issues. So we needed to know, and we didn't know really. Then managing service standards. This one was a very difficult part, because now you try to build in some level of observability into your own applications and your services you are giving to clients. But every engineer is different. Every engineer has their own interpretation of what you are requiring from them, how you want to measure the SLAs, how you want to get the health checks, how you want to know your errors, and they implement them differently. As well, you have different languages. In our company, we've used Golang, PHP, Java, Clojure, C Sharp, a lot of them. We use a lot of different languages to accommodate engineer confidence, because some come in their confidence certain languages that are good, also to grasp and use certain functionalities that those languages give us, which help. Also, and enables us to be versatile and be able to innovate very quickly. So you might have come up with a way to do a certain level of observability in Golang APIs or Golang web applications, but then how do you port that to Java? And once you have also a lot of different languages, what you end up having is that even experienced engineers understand the concepts, but then they might not know exactly how to translate them effectively into the other languages. And so if you account on another engineer, they'll translate it as best as they can. And sometimes those translations aren't the best or the most efficient way. Now you end up setting up a team. You say, okay, these guys manage our boilerplate for us. So you start having boilerplate for Golang, boilerplate for Java, boilerplate for name the languages, as many as there are that you manage in your stack. And now everybody has to keep using this, and it becomes difficult to manage because you have vulnerabilities, you need to stay up to date, you need to manage them well. And like I said, this is in the early days. You're talking about a startup. How many engineering resources can you dedicate to such work when you need to put up services and continue to help your clients in their digital transformation journey? So it was taking our focus away from what we really needed to do. So this was us back then. Don't know our latencies, don't know our service health, don't know our error margins, and it was difficult to manage our standards. Now, with these problems in mind, we started hearing a popular phrase from our engineers. I don't know. That became so popular. Why is this transaction hanging? I don't know. Why is this process not completed? I don't know. Why is this not working as we expected? I don't know. It really wasn't their fault. In a way, we had been set up to fail. So there was a lot of I don't knows. We're always trying to figure out what the issue was, what the problem was, because you have these little problems that come up, and when they do come up, they might not be a critical issue until later they cascade downstream, and now you realize we have a very big problem, and now you have to undo, come back, unravel through each of the systems back up to find out exactly what the issue is. And aside having a popular phrase, we also had a popular use of engineering time. Most engineers spend their time yak shaving. So would always be yak shaving. Because by the time we realize there's a problem, our client has actually called us that there's a problem. We don't know there's a problem before our clients call us. And usually you have about 3 systems. The error shows up in system A, but after searching and searching and searching, you actually find the error originates from system C. You've gone through A, you've gone through B, and you've ended up at C. How do you fix this? And so you always have problems where you are yak shaving. To fix one thing, you have to fix another. And to fix that, you have to fix another. And to fix that, you have to fix another. We are spending a lot of time finding out why we can't find out why, instead of actually fixing what the issue was. I might concede that those experiences and those years of yak shaving made it a bit efficient at yak shaving. But that efficiency, no matter how much it is, efficiency in yak shaving is not a good thing at all. So even though we got a bit efficient, it was still a waste of time, because you could actually have solved the problem in system C before it showed up in system B if you're observing system C. So there was no way we're going to stay with that. So that was our problem then. Most of our time was going to yak shaving. So we decided to do a transition. We decided to embark on an SRE journey, largely following the principles laid out by Google. And we thought to ourselves, we want to become a market leader one day, and we will learn from those who have gone ahead of us, like Google. And so we decided to adopt their SRE strategies. Yes, strategies. And as part of that, it wasn't necessarily like a conscious choice to say, okay, we're doing SRE, we'll go recon. No, one day we said we'll start recon. It was experimental. That was somewhere around 2018 or 2019. Yeah. So I'll start with Kong. So we got Kong, we set it up, and we started with one of our products we're working on in development. And we started using it and slowly rolled it up and rolled it out. Sorry. And now we use it throughout our stack. So we use the Kong API gateway. And every deployment we do for any client now, we always start with a gateway. We always start with a gateway first. So we go to a gateway first approach now. And from the transition, we entered a new age where in SRE, we wanted to have good observability. And what does good observability mean? It means we should be able to see our logs, we should be able to see our metrics, we should be able to see our traces. We should be able to see the logs for all our systems in one place, aggregated, stored over time. They aren't going to get lost. We can do proper searches over them to find out what exactly issues are in the system. Metrics as well to help us know what is happening to the systems, what are error margins, what are response codes, and traces. Traces is one thing we are dabbling in now. We've started in some few projects we have, but it's really proven a tremendous investment because it takes time to instrument the tracing, no two ways about that. But once you get that done properly, you can actually see and optimize your applications as well. You can monitor and track to a very fine, minute detail what exactly is happening to every transaction throughout your system or every action throughout your system. So these were the things that we looked for when we talk about observability. Now we look at what exactly we took from observability and put on our API gateway. So the observability, those three things relate to a whole system, of which the API gateway is one. So we look at exactly what we did on the gateway to help us. And the first one was application health checks. Now, this might seem like a simple thing, but this was gold when we started because prior to this, we didn't know which services were up. We honestly didn't know, and we didn't know when they were down. And so, application health checks was a big game changer for us. It really allowed us to be able to see our services and know when they're up, when they're down, get notifications when they are down, and be able to immediately remediate and fix those issues. Then metrics. Like I mentioned, we weren't able to measure, we weren't able to track. So by getting metrics of actual transactions happening real time without needing to do boilerplate code all over every time in many different language implementations, we began to see gains from there. We began to see improvements in our systems. We began to see better uptimes on our systems and better tracking, better error fixing, better updates. And like I said, tracing is one thing that we are um, we are implementing, if I could say passionately, so that we ensure that we can track very finely everything that happens in our systems. So, what does this mean for us? It means that we implemented alerts on our health checks. No health checks alerts get sent to the SRE team, as well as application health check alerts get sent to the SRE team. It allowed us to be able to start fixing errors when they happen. So we don't wait until one system needs system Z to find out system Z has been offline for the past 3 days. Or system Z has been offline for the past 1 hour. So we are able to get on top of issues immediately when they happen with these alerts. It really, really transformed our SRE and our team going forward. As well, we could now measure. And measurement is very important. We used to work with clients, and most of our SLAs were if something's critical, should take an hour to fix, to restore. If something's not critical, it should take 4 hours to fix or 2 days. Those were largely the SLAs along those lines. But upon seeing what Google does and learning from there, realize that we actually need to measure better. How many 400s are you getting? How many would you allow in a day? How many 500s would you allow? So if you do a percentile, how many of that should be 100 to be 200? Sorry, how when that should be 300s, 400s, 500s. What are your latencies? Those were better measurements. If you are doing reads or writes or queues, then latencies matter. If you are doing APIs and HTTP requests, web pages, then the response codes, the status codes matter. So we now are able to measure properly these things from the metrics. And these metrics they come readily available from Kong. You just get them, you ingest them, and then you can have dashboards, set up alerts on those dashboards, and you can track from your systems in real time what is happening. You also have that historical data to inform future decisions. So we're able to measure, and upon those measurements, we're able to draft new SLAs. So going forward in all new relationships with clients, we are bringing on this new approach to proper measurements of SLAs and using those to tackle issues, because it helps us to innovate and build better systems rather than saying if something's not critical and we give a description for it. And so in the end, when there's an issue, you now have to find out where to put it in. Is it critical or not critical, or not important, to tell the number of the amount of time you need to. And with those SLAs, in my opinion, they don't push the technology team or the technology firms to be on top of their game. Maybe it's a bit lazy, in my opinion. Maybe I've not seen ones that work very well, but the other approach where you can measure properly from metrics, real time, is better. So we are able to measure the effects of changes and updates as well on systems, and we are able to track what exactly is happening. Once you do an update, we can tell how the update is reacting to the rest of the system and be able to make appropriate changes where they need to be. And now postmortems. So before we didn't know, before we're yak shaving, now postmortems are more effective, because once a service is offline, it's not healthy, we start working and fixing that problem. And because we start at that time, the postmortem starts. The postmortem starts right at that time when the system went off, and we are able to find out exactly what went wrong and when it went wrong. We don't wait until a system that depends on it finds out for us, because previously clients tell us our systems are offline, but now we know our systems are offline before clients call. So that one makes our postmortems far better. As well, in our previous approach in that backstory, in postmortems, we had a lot of blame pointing, not in the sense of pinning it on someone, but more in the sense of pinning it on something that appears not to work. Let me explain. So, for instance, you have 5 services, and each of the 2 services have not worked. So, each of the times each service has not worked, 2 of them, there has been one service that appears to be in that window. So it gives the impression that service, which has been in that window when you did the investigation for the first service when it was offline, and for the second service when it was offline, is the problem. But it could be that that service depends on the downstream, which is the problem. And we had such a service where we thought this was a problem, and it begins to be labeled the problematic system. And so whenever we did postmortems, because we're so far removed from when actually the incidents occurred, what you end up happening is that people take the blame and they throw it, and that service has actually become like a sticky wall, and it sticks. The blame will stick to it because it's like, well, when service A also didn't had a problem, this service was in the mix. When service B had a problem, this service was also in the mix. We don't actually find out exactly what the problem is. And like I said, postmortem starts right upon receiving the alerts. So we are able to start right there and identify. And that actually changed that service's status. It's no longer considered one that is problematic. It's rather considered one that has a downstream that can be problematic. And so we put in measures to ensure that we can deal with that whenever that happens and to identify immediately. As well, in our new age, what we are doing now is that all inter-service calls, we are routing them through the gateway. There are some that don't go to the gateway because the best, is to just do network calls between the services. But because we are riding on the observability the gateway gives us, all these network calls are devoid of that. So what we want to do is to pass everything to the gateway. The gateway has now become our middleman, but in a good sense, a middleman that does all our accounting, our bookkeeping, our records keeping properly, adequately, quickly, and it doesn't hinder or impede SLAs or service times or latencies. It doesn't at all. So we are very happy to pass and route all our requests through the gateway, and we are doing that. Currently, I think we are about 80%, so 20% are through the network still. But we are slowly moving through, updating all our systems to make sure that we go through the gateway alone. There are some client sites as well where, because they were a little bit earlier, they don't have a gateway yet. They don't have a gateway. So what you have over there is they are still going about the old ways. And with this, we can, like I'm saying, we can adequately observe and every service in our stack because all the requests will go through the gateway. And I can see it on the engineer's face. When you ask any of our engineers to go and monitor or check an incident at a site where we don't have the gateway, they are less enthused about that as compared to sites where we have the gateway because you can see the difference it makes. Faster identification of problems, faster solutions, quick times to restore services, as opposed to those that don't have the gateway. So, what do we want to do looking into the future? We want to implement extensive health checks that would ensure that, like the service I was talking about, it had a downstream that was causing the problems. But because we didn't think of the downstream, we thought that service was a problem. So we are going to update all our services. Aside doing health checks to say the application is online, the application should check every downstream it depends on. So that's one thing we are rolling out bit by bit into our stack to ensure that once you do a health check on an application, you've equally done a health check on all its downstream systems. And so you know when an application's downstream is not available, right when it's not available. And that just feeds through the health checks that we have system with the alerts and notifications. Then also to change the culture. It's not easy to change culture, especially when people have a way of doing things and in a way have become set in their ways. As well, have new members join the team. And sometimes when you explain to them that we need to do this, because they weren't there when the problems occurred, they might not appreciate why it needs to be done. So changing the culture is something that we are doing bit by bit. And that's something we are investing time in to make sure that our engineers understand and everyone in the team understands as well. So, like I said, when we took on Kong, we made sure that everyone, business, engineering, technical, operations, went through the lessons on the university and would continue enrolling and adding more of our staff on to make sure that we have that grasp of it. And that brings me to the end of my talk. I think within time. Yeah. So thank you very much. And you can ask any questions that you have.